So hi guys, welcome back to my channel. And as we have already seen that in the previous video we were making the mini ETL project, and this was like uploaded as part 1. So in this video we will be like completing this project, and this will be part 2, and you can say as it is the final part of this ETL mini project. So we'll start like without wasting the time. We'll start like writing the code, rest of the code which we have started yesterday. We saw like how we have set up the project, or what are the tables we have used, and I will just show you like yesterday what we have done. So this was the part of the code we have written, and data quality was also written here. So you can see this db config, which is like read table and write table things. Another things like configuration to set up the database connecting to the tables. So these things we have already done. Now in this video we will be like writing the main part of the code, which is what we were supposed to do in this project, which is called like the ETL job. We are trying to create from taking the data from the source, transforming into through Pyspark, and then loading into the target ones, like which is our table. So let's jump directly to writing the code here. I will start because we are using the JSON file. I will import JSON, and later part of the code it will be used. Now I will, from this all db config, I will import the function this one is not required, yeah, but we need to write it here anyway. It's fine, we can import it. Read table, and another one which we created is write table. We just see like db config get jdbc url. Okay, it's already not in use, so no need to use here. Yeah, okay. So write table we have already imported. From again there is a data quality. Import so we'll import the check nulls, check row count, fine. Again we'll just import from logger, import get logger. Okay, now the next part is like we will load the config through JSON. So in there is a JSON file, we need to fetch it here. So it's a basic Python thing, and I can paste here this one. This is the path where we have the JSON file, so you can make it your own. It's nothing that much complicated. I will just make it as an alias config underscore file, and then we'll give the colon. Start writing this as config is equal to JSON dot load. So I'm just loading the file, config file. Okay, now here we need to mention it as logger is equal to get logger config. Now I will just check it as log path. So from where I'm just taking this log path, if you want to know, you can just go to this ETL config JSON. Here I am fetching this path. So what exactly this path is referring? So whenever we will run the code, whatever the logs are being generated, you can see in that path. So if you are setting this path into your system, you have to specifically provide that particular path, so that you can start seeing like where this all logs has been generated. Let's jump to this. So now it is clear here, and again we will call this Spark session, which is get Spark session. That's fine. Now this has been called. We will load the table, load tables. So here we have three main tables, as I will show you here: flood alerts, weather readings and place master. This load status is not a part of the code where we are calculating the aggregate for that particular Mizoram, but flood alerts, weather readings and place masters are those tables. I will just make it as placed df here is equal to, I will read it through. Then we have already written a function to read the tables. So this is read table, you can see here. I will define it. So you can see here, if you will see read table, I am giving a Spark, which is like getting the Spark session to connect, and again there is a table name we need to provide. So here I am just fetching the table name from the ETL, from the JSON file, sorry, just told ETL by mistake, and config here we all know which is place, sorry, here we need to give a tables, and again here we need to define the table name place master. So this table is a like key, and this is the value we are fetching it here. So this table, if you will see the tables we have taken, the place master we are fetching, it will give the public dot place master thing. Now let's move to this part again. So I will just show you this one. This is a very simple thing. I will just show you. It will give you the data. If this is correctly connected, you can just test it. It's a basic testing here. I'm not doing anything, running the final version of the code. Let's see. Yeah, so here you can see it has given a data, place ID, place name, latitude, longitude from the table. I have just row 5. It means like whoever knows the Spark, they knows like it's getting the only 5 rows. So now here I will just do it, and I will load the another 2 tables, which is like a weather df is equal to, we'll call the read table, we'll give it as a Spark. Now we will give config, we'll give here as tables. Now we'll give here as weather readings. Wrong, just check here, weather readings, fine. So this one I have given, I will copy and paste just to avoid any conflict. Weather, and again this one is flood df. So here also we will be calling read table, then again we will be putting it as Spark. Why I have given it here? So a Spark, now comma, just okay, don't need to give anything here, and just give this config. Config is like tables, and the another one is flood. What is the table name? Flood alerts. So this should also be in double inverted. I have just mistakenly written here without this, flood alerts. So now you can see we have loaded. If you want to check the data is getting loaded into all this or not, we can check it. Weather df dot show 5. Another one is like flood underscore df dot show 5, and let's run the code. Hope it works. Yeah, so we can see that they have loaded the data. Now moving up to this next part, this we can make it as delete. Now the next part is like we will provide here logging that the data has been loaded. Logging dot warnings, logging dot info. We'll just mention it here is as source tables loaded. Now moving to the next part of the code, not it's a logging, it's logger. Logger, yeah. Now moving to the next part of the code, which is our data quality check. So once we have loaded the data, we need to check the quality of the data, whether it is containing any null values, any missing values. So we have already written function here in that data quality. We will use that function directly. So to check nulls, we will pass that check nulls. I'm passing this data frame place df. We'll check based on like place id. Another one is place name, and then we will pass the logger one, and another one is check row count. So it will also check the row count in weather df. Now moving to the next part of the code, which is like filter for current month. So when we are filtering for current month, we will just let it be filter for, or else we need not to give here, just we can take some, yeah, it's fine that we can check, mark it as comments. Filter for current month, just take something like that, month date is equal to config, sorry here it has not been mentioned, month date config will be taking it as like month date. Now moving to aggregating part, aggregating data. So when we are aggregating data, we need to define weather is equal to weather underscore df dot group by, we are using here Pyspark functionalities, place id dot aggregate, again average. So for what we are taking, it is like temperature. So okay, now I will tell you, there is something that I need to tell, because which I have not done in the initial part of the code in this writing ETL part. So here you can see there is an LO underscore line. Why it is giving? Because we have not imported this. So from here I will just be writing down, one second, where I need to import. Okay, I can do here. So from Pyspark dot SQL dot functions import. So once we will import this average, you can't see this anymore. Now this has been removed. Okay, fine, let's move to the next part. Average, we are finding it as a temperature, so, and we can give it as an alias. Alias will be like average underscore temperature, okay. So let's move to the next part, comma, again now using sum. So if we are doing something sum rainfall, okay, we will give an alias, same concept will be used, and it is total rainfall. Fine, now we'll move to the, so here I am using one alias. Let's give here average sum as sum. Now you can't see any error. Fine, here again there is an average for humidity. So these all columns are present under that humidity. We'll give the alias average humidity. This is fine. Now we can see this part of the code is already done. Let's move to the next part, which is weather. And if we want to see whether it has been loaded, it's fine, we can see it as I have already shown you guys. Let's run this one. Yeah, so here you can see this, the weather aggregate has been showed, the average temperature, total rainfall, average humidity. Let's remove this one. It was just for checking. Another one is flood aggregate. So flood underscore df dot, okay, group by, let's do this one, group by. Again it will be from place id, then using aggregate function, then using a max one. So why it is giving here as max underscore, the same rule will be applied. Max, if you will see now it has been removed. We'll just take it as in water label, the max water label. Now sorry, dot alias, and it will go like max water label. Now here we can use another one, the max flood risk label dot alias. And that has also, and now we have already aggregated it. Again let's jump to the next part, which is like join with the place master table. We'll do this here, which is like we are just going to find out the summary or the final df. We can write it, no, we can write out summary df anyway. It is summary df is equal to placed df dot join dot weather df weather aggregate comma on, based on what we are just adding it. It is like place id, which is a very common column in all these tables, and how we are adding it, we need to define these properties. So how it will go, it will go like left. So left we are using. Now let's again do this dot join. Yeah, it will looks good actually. So another one is flood aggregate on, same it will be also on place id. And if we'll see how, place id, if we'll see how, so this will also go as left. Now there is something that is a bit of more use in a Spark, you will see here, which is call, and then taking as place id, we are just selecting the column which we want in the final output table, comma call. So you can see here there is an yellow line. I will just import it here. Call. Now another one is place name, another one is call average, temperature, call total rainfall, comma, call average humidity, call, we'll use another one, max water level. So these all columns we want, max water level, and call another one is flood risk level, flood risk level. Now once we have done this part, let's move to with column. So I will explain here a bit like why we are using with column. So with column is used to just create a new column and give it a value. So when we are creating a new column which is month date, and we want to use, these are very common things in Pyspark, you need to revise it throughout. We need to define it here as to date also. So wherever you are finding it something yellow, just define it here to date. Yeah, so now when we will use it, it will show you to date. Okay, so let also now, yeah, so you can see here it is not giving any error. So lit, I will tell you, firstly I will tell you what to date will do. So it will take date, it will change into a desirable format of the date, and lit will be filling the values like wherever these values will be. And if you want to fill random values, just let's example that there is an empty column and we want to fill with the same value for that particular column, so we can use pass the value under that lit, we can use that lit, and it will month dates, we want to fill with the month date, comma, month dot with column. Node status ID, comma, let config load status ID. It is almost done here now. Yeah, so it's done already, we need not to do anything now. So our final summary df is ready, and again we are just going to load into a table, load into the final output target table. So our target one is like, as I already shown, I will show you Mizoram weather someday. Let's show this, select a star from Mizoram weather summary, and we can run it here if you want to check that data is available or not. One second, continue. Yeah, so there is no data here, we can directly load, the table structure is present. I will just start writing the table, write table. So we can use this write table, we will pass the value of the df, summary df, we want to load the config in which table we want, so we need to define it here, tables, again we need to define in which table we want. So it is like our Mizoram weather summary. Okay, so it has already been write down. Now logger dot info, we'll just see and we'll pass here final table data has been loaded successfully. So this message we can give it. Okay, fine, just move again, we will stop spark.stop, and now there will be logger dot info, we can provide it at the end. ETL job completed successfully. So now we will just run it. Okay, let's go one time before running it. Fine, there is no error in that code. If it is there something, we'll just see here. Is no problem. If there is something, we can resolve it. Let's run this. So what exactly it is doing, I will just go through that after running into. Okay, there is something which is it is giving an error. Okay, sorry, this name is different. I think your target somebody is there. I have given directly the value. Let's jump here. Command B. Sorry, now we will just run it. Yeah, so it has already been successful. And if we want to see, we can see into the logs. So you can see here final data job has table data has been loaded successfully, ETL job completed successfully. You can see the time, it's 1:49 am 10th of June 2025. So now let's see the data has been loaded into the table or not. Yeah, so you can see that the data has been loaded. We all can see these things. We can analyze the table wherever you have loaded. It's a 50 columns. If you want to check the count also, we can check it. These are the simple SQL things you can do from your side. So 50 columns, 50 rows has been loaded. And if we want to see the data, it's fine, we can run here. So you can see load status ID, flood risk level, max water level, average humidity. Place ID is not in the order. Just because why it is not in the order, because it has taken the place ID, place name, month, date, average temperature, and total rainfall. So now I think you have already got it what exactly we have done. I will just go through the code once last time. So here we have started importing JSON. These are the functions we have imported. We have created, this is UDF. So this is UDF means user defined function, which we have defined, and we have taken and imported from the different folders of the Python. Now data quality logger, we all know like from where we have imported it. Pyspark.sql functions, like it's an inbuilt function. So average, sum, max, call, trunk to date, lit. So there will be a confusion for you that if you are seeing on the screen that why we have taken or why I have taken it as sum underscore. So this is to just avoid the conflict between the Python function and Pyspark. You can use it sum, there is no problem, because these are inbuilt functions, there is no problem in that. So this is the config JSON file we have provided. And another one is like this logger Spark, we have called the Spark session to start. Place df, we have just, these are the data frames we have loaded by reading the table for that particular table. We have loaded into the data frame. Now source tables loaded. Again we have checked the check nulls, check row count, which from data quality. You can check the uniqueness also by creating any function. Month, date, weather aggregate, flood aggregate, these are all things like whatever we want, and we have used the aggregate functions here. Summary df, it is finally like we have joined two tables, one place df and another weather aggregate and flood aggregate. We have selected these columns from select call. Lit we have used, to date we have used. These are the Pyspark frequent functions we have used. So you can also use from your site to just practice it. This is a very easy basic Python mini ETL, Pyspark mini ETL project, which is basically saying you how ETL works from source, extract, transform and load. So when we are taking some data from source, we need to transform on based on that operation or based on the requirement. We use different programming frameworks just to transform those information to make it readable, to make it available to the particular final downstream team. So that what we are calling it. When you are working in a professional team, you will know what the terminologies are, and you need to very cautious about writing these programs. So you need to know end to end from Pyspark functions. There should be a very strong Python knowledge also. It is not like a basic knowledge will be okay to go. I will recommend to just go and revise all Python frameworks, Python Python modules, how the data structures in Pythons work, like list and all. And thank you guys just for watching this video. I will be coming back with one more interesting topics from ETL and data engineering part. So let's close this here for the mini ETL project. Thank you once again for watching this video. Thank you.